Hello, everybody. Welcome back. Today, we're going to go ahead and continue with section 7.2, the confidence intervals for the mean when your sigma is known. All right. This is going to be for, oh, I'm sorry. This should be for known, right? Not known would be for 7.3, right? So when your sigma is defined, right? When your sigma is known. All right. So we're going to go ahead and continue the concepts, right, from 7.1. I understand 7.1 was pretty short, pretty straightforward, right? We were dealing with confidence and intervals, right? So if you look at your page, what is it, page 364, right? On page 364, right, we see we're given a curve, right? The confidence intervals are going to be cut off at these points, all right? And just like from the previous sections, right? Confidence level equals 95, right? We had mentioned that there's symmetry, right? Whether there's symmetry applied to this, right? So the area under this curve, right? The area under this curve at that cutoff point, right? At this cutoff point is we're adding both of these together, right? This would be my alphas, all right? This and this would be my alpha, right? It is my area under those tails, right? But if you only want to look at one end, right? If you only want to look at one, right? This here would be alpha divided by 2, right? So you have one pizza pie, you cut, right? You divided it by 2. What's the size of it? It's just a half, right? Right. So that's pretty much what we're going to be doing here. And then more specifically, we're going to be finding out, right, the z value. What is the z value there, right? What is the z value there? All right. So let's go ahead and get started. All right. Let's go ahead and get started. All right. So problem number A, right? Let's go ahead and do problem A. All right. So I need to find z sub alpha divided by 2 for the 90%, right? 90% confidence interval, right? 90% confidence interval, right? So, right, the first thing we want to go ahead and do is turn this, or we don't like dealing with percentages, right? So I'm going to go ahead and divide that by 100, right? And I see that this here gives me 0.9, all right? 0.9, right? So to find my alpha, right, is going to be one whole piece, or 100%, minus that percentage, or minus that decimal, all right? Meaning there's going to be one full piece minus 0.9, all right? So my alpha, right, on both ends, to put together, it's going to be 0.1, all right? 0.1. Meaning if you want to go ahead and find alpha divided by 2, right, well, you already know what alpha is. Alpha is just 0.1, right, divided by 2, meaning my alpha divided by 2, right, would be 0.05, right, 0.05. Right. So right, this here would be the like the area, right, the edge point, right, from those tails, right, for each individual tail, right, for each individual tail, right. So this is going to go ahead and be my first step, right? My second step, right? My second step is going to get one full piece, right? I'm going to go ahead and get one full piece, and I'm going to subtract it from that alpha over 2, right? In other words, so this is 1 minus 0.05, right? And what does this give me? Right, this gives me 0.9500, all right? And we're going to go ahead and be applying the same thing as before, all right? We're going to go ahead and apply the table E, all right? Table E, the standard normal distribution table, all right? And just like before, right? What am I doing? I'm finding that value in my chart, right? So let's go ahead and find 0.9500. All right, it's more than 0.5, so I know that has to be on the right side towards the positive values, right? I'm gonna look for 0.95. Uh-oh. Right, 0.95. What am I looking at? Somewhere between there and there. All right. Yeah, I lost it. Oh, I ended up losing this. Where am I at? 0.95. Okay, right here. All right. I got this value here, right? 0.9505, right? If these are both, if the value you're looking for is exactly between them both, right? You're gonna rise up, right? You're gonna rise up to the next upper value, right? So I see here, hey, I'm exactly between, right, 0.4, and I'm exactly between 0.5, right? The distance is identical, right? You're gonna scale up, right? So this value here, my z-score here would be 1.65, right? So this here would be 1.65, right? Meaning my z alpha over 2, right, for my 90% confidence interval is 1.65, right? 1.65. Let's go ahead and do another one, right? Go ahead and make this a little bit bigger, all right? All right, so I'm looking the same thing, right? I'm looking for z sub alpha over 2 for the 88% confidence interval, right? So I'm going to, the first thing I want to go ahead and do is, I think this was probably a little bit confusing. So let me move this up here. Probably up there. All right, let's go ahead and move that up there. All right, so the first thing I wanted to go ahead and do is turn that 88 into, I want to go ahead and get rid of, it should be 100. I want to go ahead and get rid of percentage. All right, so this here is going to give me 0.88. All right, so I know it's going to be alpha is equal to 1 minus, right, that confidence interval, which is 0.88. All right, and this here gives me 0.12. Very nice, right? Very nice. So I can say, all right, the next step, right, if we want to go ahead and do this in steps, this is the next step would be I need to look for alpha, right? Because so this 0.12 is for both tails, but I'm only looking for one tail. I'm only looking for alpha over 2. All right, so I'm going to do alpha over 2, which is 0.12 over 2, all right? And this here ends up giving me 0.06. Right, that ends up giving me 0.06, right? And the final step, right, would be 1 minus alpha over 2, right, which is 1 minus 0.06, right? And I see here that this gives me 0.9400. All right, what I'm going to go ahead and do, right, I'm going to go ahead and find that 0.9400 on this table, right? 0.9400 on this table, all right? Both of these values, right? Both of these values are, let me see, right here, right? I'm looking at these two here, all right? 0.940 is between them both, all right? This is 6 away from 0.94, and so is this one, but I'm going to scale up, all right? So that means I'm going to be looking at this one, all right? So this is here is going to be 1 point, what do we think? 1.56, right? 1.56. All right. 6, right? So in other words, z alpha over 2 or an 88% confidence interval is 1.56. All right. I'm going to be giving different examples of these, right? So we can go ahead and get the rhythm flowing, right? So, all right, if you want to say this is step 1, this is step 2, this is step 3, and then this is step 4, and then last but not least is step 5, right? Finding it on your chart, finding the z value on your chart, then definitely, right? Whatever helps, right? Whatever helps. Okay, let's go ahead and go on to our next problem. All right, so I have here, all right, I have a random sample of 47 cars in the drive-through of a popular fast food place. All right. So we said one of the first things we always want to do is let's write down what they're giving me, right? Let's write down the given, all right? A random sample, right? That's my sample size. This is going to be 47 cars, all right? Restaurants revealed an average bill of 16.89 per car, right? That's going to be my average, right? So this here is going to be my average, right? This is 16.89. The population standard deviation, right? My sigma, right? That's a given. It's known, right? 5.72. Estimate the mean bill for all cars from the drive-through with a 94% confidence interval. All right, 94% confidence interval. Right, and now we see here the importance, right? So in other words, this is the formula that we're going to go ahead and find, right? This is the formula we're going to go ahead and find, right? The formula for the confidence interval of the mean for a specified alpha when my sigma, right, when my standard deviation is known, all right? Right, and here are some, right? You'll find out that your books has very if you're dealing with 90% confidence interval, 95 and 99, right? If you do so many of these, eventually you're going to know, right? You're going to know the answer to them, right, immediately. But do not, right? Do not. Sure, you can check your work by checking it here, right, on your book. But you need to show your work, right? I need to know that you know how to find the Z alpha over 2 for 90%, 95, 99, 98, right? So please, please, please show all your work because that's how it is going to be in the exam, right? If I ask you to show your work and for 99% confidence interval, you just equal it to 2.58, right, you're not going to get any credit. I need to know that you know how to find that, right? In case it's not a known value, right? Whatever it was, like, right, like 90, right, to like 98, right, or 93 or 92, all right? So let's go ahead and find that, right? So it's for 94% confidence interval. That's the first thing I'm going to go ahead and do, right? That's the first thing I'm going to go ahead and do. So we're going to go ahead and do alpha. Oh, wait, the first step is turning that into, right, the first thing I want to go ahead and do is turn that, get rid of the percentage, right? So this here is going to be 100. You find out that it gives me 0.94. All right. The second step I want to go ahead and do is going to be my alpha is equal to 1 minus that value. All right. We find out it gives me 0.06. All right. The next step here, right, would be to do alpha over 2. All right. Yeah, it's going to be my alpha over 2. All right. So this here is going to be 0.06 over 2, which gives me 0.03. All right. 0.4 is going to be 1 minus alpha over 2, which is 1 minus 0.03, which is 0.9700. All right. So now I need to go ahead and find out what is that Z value, right? That corresponds to that 94% confidence interval, right? So I have 0.9700. All right, let's go ahead and find that 0.9700. Right here, right? Right here. That's pretty close, right? 99 is closer than 06, all right? So I would choose this one. That is 1.88. All right, 1.88. All right, so this is 1.8. And this is exactly what we need, right? This is the important piece, right? It's here. This is a very important piece, all right? This here, and all these values here, all right? These are the very important pieces because I need it, right? I need this to find these values, right? I need it to find, I need to find my endpoints, all right, for this formula, and here we are, right? So my formula here, right, for it's going to be my mean minus that Z value that you found over times, I'm sorry, sigma over square root of n bounded, all right, x bar plus Z value sigma over root n, all right? And if you realize I have everything that I need, right? I have everything that I need, right? Meaning my x bar, right, was 16.89 minus that Z value, which is 1.88 times sigma 5.72 divided by, let's go ahead and scoot this a little bit over, right? Up there. Divided by the square root of n. What was my sample size? 47, right? is less than mu, less than the same thing, right? So in other words, it's going to be the exact same thing. The only thing that you're changing are those bounds, right? The one is going to be to the left and one is going to be to the right. And that's differentiated by that plus or minus. All right. Those final answers are going to be different. All right. So let's go ahead and plug that in, right? So 16.89 minus 1.88 parentheses 5.72 divided by the square root of 47. All right, this here ends up giving me, let's do 4 decimal places, right? I get 15.3214 less than mu. All right, and I'm going to do the same thing, but I'm adding now. All right, so this here, right, I'm doing 4 decimal places, 18.4586, right? All right. So, all right, and this just means that estimate the mean, right, for all the cars from the drive-through, right? So that means that the mean bill, right, the average bill, right, for that sample size of 47 with a 94% confidence interval is going to be between $15 and that much change and $18 that much change. So since we're dealing with monetary values, right, actually we want to use 2 decimal places, right? So this is $15.32 below, what's that, 18.46. All right, so that there would be my final answer. Okay, now here, all right, let's go ahead and have here a different type of problem you may find is the number of faculty at 20 randomly selected state-controlled colleges and universities with enrollment under 12K students are shown below. Use this data to estimate the mean number of faculty in all the state-controlled colleges and universities with enrollment under 12,000 with a 92% confidence, right? Assume that your sigma, right, that your standard deviation is 165.1. Assume that the population is normally distributed, all right, and normally distributed, right? So yes, I'm going to end up using the same formula, all right? I'm going to end up using the same formula. So let's go ahead and bring this over, all right? Let's go and have it here, right? All right, so what do we need, all right? I need an X bar, right? I need a sigma, I need a sample size, and last but not least, I need that Z value, all right? I need that Z value. So my average, right? Well, I know my sample size, or what's my sample size, right? 20, right? So that was given. I'm told that my sigma is 165.1, right? My standard deviation. Right. And you may be asking, how do I find my mean? How do you find your mean? All right. All right. We said that our mean, right? A little throwback, right? A little callback is the sum of all your X values divided by N. All right. All right, you may go ahead and input these by hand, or if it gives you the option to send your data to Excel, you can go ahead and do that and sum it all. All right. As you know, your exam won't have values like this. All right. As big. All right. Pretty close to it actually, but you know it won't take up much of your time. All right. You'd find out that whenever I add these up, this should give me 7,118. All right, divided by 20. Meaning that my mean, right, my average to 1 decimal place should be approximately 355.1. Let me go ahead and triple check, all right? 7118 divided by 20. Yeah, 355.9, all right? So at this point, I pretty much have everything that I need. Let's go ahead and find that Z value, all right? Let's go ahead and find that Z value. All right, so I see here, right, 92%, right? So we said step 1, right? Let me fix this real quick. And we're back. So my first step, right, is going to be, I want to turn that 92%. This gives me 0.92. Right, my second step would be alpha is equal to 1 minus 0.92. Right, this gives me 0.08. All right. Step 3 would be alpha over 2, which is 0.08 over 2, which is 0.04. All right, step 4 would be 1 minus alpha over 2, right, which is 1 minus 0.04, all right. 0.9600, all right. And last step, all right. Is here, when I pull that up on the table, 0.9600, right? 0.9600. That looks familiar, all right? That looks very, very familiar. And these are one of the ones we worked out earlier. Was it? Oh, no, I think it was 0.9600. All right, there we go. Oh, no. Oh, my mistake, right? 0.96. Oh, there we go. It was 0.97. That's the one. That's why I got it confused. So it's this one here is closer than that one, right? So my Z value would be 1.75, right? 1.75. 1.75. This is 1.75. Hey, at this point, I have everything that I need, right? Let's go ahead and plug everything into the formula, all right? Let's go ahead and plug in everything into the formula. All right, my formula here, all right, let's go ahead and write it out again, all right? The more we write it out, the more we're going to get familiar with it, all right? It's going to be x bar, all right, minus a Z value at alpha over 2 times sigma over square root of n, all right, less than mu, less than that same x bar plus that Z value times sigma over root n, all right? And let's see here. Okay, right. So we know here, right? Where was I at? All right, we got this Z value, right? So at this point, I can go ahead and plug everything in, all right? Let's go ahead and plug in 355.9 minus the Z value that I got, all right? That was 1.75 times my standard deviation, which was 165.1. That was given, all right? That was given. For the test, right? I may give you all this data, right? And I might ask you to find everything, right? I may ask you to find all these three, all right? Everything, right? It can just be a set of numbers. So be ready for that, right? Let's remember how to find our standard deviation if we forgot, all right? Square root of 20. Smaller. Minus less than 355.9 plus 1.75 over 20. All right, let's go ahead and see what this ends up giving us, right? Let's see what do we get? All right, and of course, right, if you want to go ahead and pause the video, all right, you work this out, definitely go ahead and do that. 20 double close paren. All right, and here I get 291.2944 less than mu. All right, I can go ahead and go back, do the same thing, and just change that negative to a positive, right? This here gives me 420.5056, all right? And there we go, all right? That's going to be the mean number of faculty between those values, right? Very, very nice. All right, let's go ahead and see what else we got. We have here example number 4. All right, gasoline usage. Yeah, very nice, gasoline usage. All right, a random sample. If a random sample of 36 drivers use an average of 752 gallons of gasoline per year, the standard deviation of the population is 32 gallons, right? Part A, find a 99% confidence interval of the mean for all drivers, all right? For the mean for all drivers. So let's go ahead and, where's my favorite table, all right? There we go. Let's go ahead and move this here, all right? Very nice. There we go. All right. So right, we're gonna have to go ahead and find my z over, right, my z value of z alpha over 2, value for 99%, right? To go ahead and save time, all right, you'll find out, right, and you know how to work all of these, right? You find out with that 99% confidence interval, right? This ends up coming out to 2.58, right? The z value ends up coming up to 2.58, all right? I have my n equals 36. My average x bar is equal to 752. And the standard deviation, right? My sigma is 32 gallons, right? Again, we're going to go ahead and plug that into the formula, right? We have everything that we need. All right, we have everything that we need to plug it into our favorite formula, right? And you'd find out, right, when you work these out together, right? Please work this one out, and you should get 738 bounded, right, between your mu and 766, right? So your mu is bounded between 738 and 766, all right? 738 and 766, all right? Very, very, very nice. All right, and for this question here, right, you won't be asked this specific question. You don't have to worry about this one. All right. So very, very nice. Let's go ahead and move on to example 5, right? Second. Right. Let's go ahead. Now we're going to use a different formula, right? Let's go ahead and make this a little bit larger. There we go. All right, so cost of pizzas, right? A pizza shop owner wishes to find the 95% confidence interval of the true mean cost of a large plain pizza, all right? For a large plain pizza. How large should the sample be? How large should the sample be if she wishes to be accurate to within 13 cents? Ooh. Okay, very nice. So that's a margin of error. A previous study showed that the standard deviation of the price was 23 cents. Round your final answer to the next whole dollar. All right, to the next whole dollar. All right, so if we look here for the formula for the minimum sample size needed, all right, the minimum sample size needed for interval estimate of the population mean, all right. What's going to be different here is going to be, now we're solving for our n value, right? We're still going to have to find our z alpha over 2. The sigma is going to be giving. And now we have to go ahead and locate a new variable, which is going to be e, right? My margin of error, all right? Let me go ahead and find that sample size, all right? All right, so what's given? All right, so I need to find my z alpha over 2 for the 95% confidence interval. All right. How large should the sample be if she wishes to be accurate within 0.13? That is my margin of error. 0.13. My standard deviation is 0.23. All right, and that's really all the formula needs. All right. Again, right, we're going to go ahead and follow all 5 steps. Right, you're going to follow steps 1 through 5. Show all your work, and right, and you'd find out that this here ends up giving me 1.96. All right, and it's still the same steps as the first 2 problems, right? First, the first problem had 2, 3, 4, I believe 4. All right, so let's go ahead and plug this in, right? So my sample size should be z alpha over 2, which is 1.96 times my sigma, which is 0.23. Divided by my error, 0.13, and I'm going to square this. All right, let's go ahead and see what that ends up giving me. 1.96 times 0.23 divided by 0.13. All right, this gives me a pretty large number. I'm going to write these all out, right, in case you only know 3.467692308 squared, all right? Or to go ahead and square that, all right, let's just say 4 decimal places. All right, I'll do 12.02, what's that, 49? All right, and so round your final answer to the next whole number. My next whole number, right? So this is going to be 13, right? That there is going to end up being 13. All right. So the owner needs at least a sample size of 13 pizzas. All right, 13 pizzas. All right. Pizza right there. All right. Let's go ahead and move on to the next example. That's it, right? This is all what we have here, right? So the majority of this section, right, we're going to be using this formula here. For the remaining few ones, we're going to be using this one here, locating, right? You're giving the margin of error and you need to locate the sample size, right? So you might be saying, hey, why are we moving up the sample size? All right, because a sample size has to be a whole number, all right? So we had 12 and a fraction of some, therefore you're going to round up to the next whole one. So it's going to be 13. Right. And thank you very much for watching and enjoy the rest of your day.